Okay. Good evening, guys. Let's get started. My first objective today is going to be to take a look at your ASA 9.x. Faisal, I'll record and I'll send you the link. We probably won't finish everything over here, but that's my first objective. To take a look at the 9.x firewall. What does it allow us the ability to do, and what are the different components of your ASA type of setup? Give me 1 second, we'll get started. Just need to connect up. One second. All right, so the plan is to take a look at the 9.x firewall. But before we go on, although we did talk about it the last time around as well, let me just briefly give you an overview again of the different firewalling components that we have with the new flavor of 9.x. If you guys remember the last time around, I did create this document for you guys. All right, just to give you an idea of the different product lines that you have with the 9.x series. So let's take a look at it again. In your new version or new flavors of 9.x that you have, or new flavor of firewalls that you have, this is the thing that you need to be aware of. And this is where it can get confusing if you haven't seen it before. And we will be taking a look at all these different things as the course progresses. But just to give you an idea where we're at and what are the different things that are going on. 9.x is the old firewall that we used to have. The 8.x, like 8.4, 8.6 type of firewall, it comes in two flavors. The ASA comes in two flavors. It comes in either the appliance, and most of the things that you see over here on this diagram come in two flavors, either the appliance or the virtual box. The functionality of both the devices is the same. Okay, so you have a firewall 9.x, which comes as the ASA firewall, either as a virtual appliance or a physical appliance that you install on it. In the older days, you would have your IPS, which was your Cisco IPS. Cisco bought the product called SourceFire. And that SourceFire product, they changed it, revamped it. They called it the Firepower product. So Firepower is the new IPS that Cisco puts out. They also call it the NG, Next Generation IPS. All right, two separate devices. Again, the Firepower device comes in two flavors, either as the appliance or it comes as a virtual box. In the older days, in the ASA firewall, you also had the ability to have a small module called the AIP SSM module. The old Cisco IPS could be inserted into the firewall as a insertable module, which was called the AIP SSM. You have the same type of functionality where you could put firepower within the ASA if you wanted to. It's an option. You can take advantage of that. That's not a new thing. That used to be in the older one as well. So your ASA would be integrated with your IPS. The same thing can happen over here, but it's an option, or you can have it not integrated in, but as a separate appliance. Whether it's an appliance or a virtual box, it doesn't matter. Okay. Now the additional thing that they've done, which was not there in the older versions, they have given you the ability to do advanced malware protection, which the old IPS did not have the capability of doing, or had limited capability of doing. Now they have a full-on network advanced malware protection device, which is again an appliance, it's software, it's a license that you can include with your firepower. So that's your AMP, advanced malware protection. What's the difference between AMP and firepower? Firepower, which is your IPS, checks for what? Network packets, and checks for well-known attack packets based on a database, based on anomalies. It can check based on changes in patterns. It will check that. That's what an IPS does. What does AMP do? AMP checks the files that are getting transmitted over the network. Actually opens up the file that is maybe an attachment inside a packet that's gone through, whether it's an email, whether it's a normal packet. It checks the file for what? For malware. So it takes it to the next level. All right. Whereas the IPS does not check the file itself. It just checks the network headers and the content as well, but not content as a file content of the data portion of that particular packet. Makes sense? Everybody okay with this?
Yes.
All right. So this is the old stuff. This is still there. When I say old, I mean it's in line with what used to happen prior to 9.x. This is still here as these different devices. The only difference over here is in the older days, in the 8.x time, most of the stuff was done based on appliances. The ASA was an appliance, the IPS was an appliance, AMP was not there really. So in the newer one, they give you the capability of either doing it as an appliance or as a virtual device. And depending on which way you have it, you can go that route. You can either buy the physical appliance or you can buy the VM that can be integrated with ESXi. Good, everybody? Everybody understand that? Now, in addition to that, they also have now come up with although it's about a year old, they have come up with another device, another product called the Firepower Threat Defense. Also known as, or commonly known as, FTD. What is FTD? Well, FTD has all these functionalities, whether it's a firewalling functionality, whether it's the IPS functionality, whether it's the malware functionality, the AMP. All three things included in one appliance, one box, one product. Again, you might buy an FTD box, but choose not to do IPS, or maybe you chose not to do malware. That's entirely up to you. That's license-based. But the device, the FTD device, has the capability of doing firewalling, the IPS portion of it, or the malware portion of it. The iOSs that you're using on the ASA and FTD are different. The ASA iOS is in the 9X series right now. All right. The FTD operating system is called the Unified OS. The Unified OS that you have, or iOS, whatever you want to call it, is in the 6.x series. All right. Not only that, the firewalling that you do in the FTD series is a little different, and we'll go through that when we go and take a look at the FTD product. But I want you guys to understand where we're at and what are we going to be doing. We're going to be taking a look at what? The ASA firewall 9.x as an appliance first. Then we'll take a look at the firepower appliance, which is the NG-IPS. Then we'll take a look at the AMP. Once we're done with that, it becomes very simple for me to show you the FTD product, which is basically a combination of the three boxes, with the firewalling being different. The main difference over here is not the firepower and the AMP, which is pretty much the same. It's the firewalling which is different in FTD. Now, one more component that you need to be aware of is the Firesite Management Console, or Firesite Management Center, FMC. This over here. What is this? FMC is another virtual box. It's a software, it's a virtual machine, which allows you the ability to manage all these products from a central location. Not just one, each of them. You have the ability to manage multiple FTDs. Let's say on your network, you had implemented multiple FTDs. All right, in different parts of your network. You might have a separate ASA 9.x, and you had a different NG-IPS, the firepower one. All of this could be centrally managed from where? A single FMC. This is your management center. Does that make sense? So this is a software that you browse into, HTTPS into it, into this IP. Once you HTTPS into this IP, then you set up a relationship between the FTDs or your IPSs into what? The FMC. So that's what this is. This is your management center. Although this part is done from the console, still from the command line, these things are all graphical, only managed through FMC. So this is the only one that will actually allow you to do it like the old ways, using the command line. The other one, the firepower, the AMP, and the FTD is all done from the graphical interface of FMC. So FMC is a requirement for either FTD or firepower by itself or AMP. Do you guys remember, if you have worked with the IPS device in the past, IPS was managed by IDM. Think about FMC being a glorified IDM, because it also has the capability of managing what? Your firewalling functionalities, your AMP, your IPS, all in one place. Not just one, it can manage multiple devices at the same time. And I'll also show you some of the advantages of doing it using a centralized console, because when you create objects, you have the ability to reuse the objects on different FTDs. We'll take a look at that as we go through that. You understand where we're at, what the big picture is. Any questions about this so far? Again, this should be a recap from what we did the last time around, but again, understand where we at, what are we attacking right now. Our focus right now, today, we're going to start with this part over here. And then move over here, and finally into this guy. Clear? Any questions with this? All right, ready then? Let's take a look at the firewall 9.x. How many people have worked with 8.x before? 8.4 or for that matter, what do you call it? 8.4, 8.2. How many people have worked with that? 8.1, okay. It's going to be a little different. How long will it take to complete this whole picture? Whatever time it takes, man. Depends on how well you take it. Most probably about 2 weeks. This week and next week, but might happen quicker or longer, depends on how you take it. All right. So Shiv's work with 8.1. How about 8.2, 8.4? Anybody work with the firewalls before? Yes, no? Nope. Yep. Okay, mixed bag, right? All right, enough no's. So we'll get started with the blank firewall. What does a firewall do? Okie dokie. So what is a firewall? Essentially, a firewall is a router. It is a router that has certain or has its hardware fine-tuned for security. Whereas the router is fine-tuned, the hardware is fine-tuned for routing, it has more memory allocated, more caching done for forwarding traffic. In terms of firewall, it is a router, it has the routing capabilities, but its hardware is fine-tuned towards security. The basic functionality of a router is to route, right? / connect. The basic functionality of a firewall is to block. There's certain rules that you have on the firewall. We'll take a look at it. Okay, understand that first. The firewall over here, the firewall can do routing. It can do static routes, it can do RIP, it can do EIGRP, it can do OSPF, it can do BGP, it can do any routing protocol. Not any, but most of the routing protocols. Having said that, it's not meant to be a full-on router, but in terms of learning routes from its neighbor, it can do that. But although it does it, it doesn't mean that all traffic is allowed to flow through. And that's the first thing that I want to explain to you guys. So let's say I have an environment. I'll pick up a firewall over here. Let's make this my firewall over here, or let's make this a router. That is correct. And yes, we are on 9.x. So let's say there's a router on the outside. This is going to be my outside router. This is my inside router. And then I have an internal segment over here as well. So I'll connect them up. Think about this being my outside network. Okay. Actually, this one I want to take off. Instead, I'm going to put this picture for my firewall. Okay, this is my firewall over here. This is my outside, this is my inside. Let's do a simple network over here. This is my outside router. Let's call this router 2. This is my outside router over here. This is the router that connects me to the internet. Okay, so router 2 connects to the internet. My edge router, my firewall's over here. This is an internal router, which might be connected to different segments internally. All right, let's put some network addresses over here. Let's say this is my outside network. This is 192.1.20.0. This is my public address, and this is my private address. For right now, my internal address is also public because I want to take care of it based on the routing. I'm not doing NAT yet. I'm going to show you NAT next. So first thing I want to do is just show you the forwarding of the traffic, the normal forwarding of the traffic. This one over here should be blue. So I'll just overwrite this here. All right, so these are my, okay, and my internal networks over here. Let's also put some addresses. 1.0. All right, this is my network that I have over here. Everybody okay with that? Now, when I configure it, initially configure this device as you would on a router. With one subtle difference, there are certain things that you need to do specifically on the firewall. If this was a pure router, all I would need to do is configure my interfaces. I would configure this interface in this IP address, 192.1.20.0 range. I would configure this IP address in 192.1.10 range. And I would configure the router over here, probably point a default gateway towards him, and create some static routes on a router 2 towards 192.1.0, 2.0, and 3.0. Basic routing. And if this was a router, let's say hypothetically this was a router and I have enabled routing on it, I should be able to reach from R1 to R2. Agreed? If this was a router, a pure router, right? If I configure routing, whether I configure a static route or I configure dynamic routing on it, I should be able to reach from 192.1.1, 192.1.2 towards R2. Everybody, you understand that? If I do normal routing over here. Now I do the normal routing, connectivity is established. Now with a firewall, there's certain basic default rules that come into play. The first default rule that you need to understand. Oops, not this. So you don't need that. Interface config. The default rules or default things that you need to be aware of. the interface, besides the IP configuration, which is your IP address subnet mask, requires two additional parameters. All right, what are the two additional parameters that every interface requires on a firewall? The two parameters are, number one, you need to have what is known as a name assigned to it. Name is not a description. Name is something that as you progress in your configuration of the ASA, whenever you need to point to this particular interface, you don't point to gig 1 or gig 2 or gig 3, you point to this name. This name is not case sensitive, but it does preserve the case. I'll explain that as we do it. I'll explain what does it mean to preserve the case as we do it, but it is not case sensitive. The other thing that you also need to have besides the name of the interface is what is known as a security level. Security level determines how secure this interface is. So for example, the highest security level that you can have is 100, which is assigned to your internal network. So if you look at your diagram over here, this network, this firewall has this internal network going towards R1. This is where my corporate network is. The corporate network over here would be a security level of 100. The interface facing the internet is the least secure one. It should be 0. So the security levels go from a number of what? From 0 to 100. This is being the highest towards your corporate network. This is the lowest. This is towards what? The internet. Okay, everybody okay with that? Good. So when you assign, when you go to a firewall, you need to assign these two parameters in addition to your IP address. And obviously you need to bring the interface up. So far, so good? Now, there's certain things that you need to be aware of as well. When you assign the name to the interface, it automatically assigns a security level to it, as long as there was no security level configured manually. So if you had not configured it manually, it would automatically assign a security level to it as soon as you give it a name. The default security level assigned to an interface is 0. So if you don't assign it, it'll automatically assign it a security level of 0. Okay? There is an exception to this rule. The exception is the name inside as the name of the interface. If you assign the name inside to the interface, it will set the security level to 100. That is correct, Arjun, by default. So the only one that is not going to be 0 is the word inside. The word inside, not internal, not private. It has to be the word inside. And make sure that there is DMZ. Forget about DMZ or any other interface. As I said, except for inside, everything is set to 0 by default. Any interface name. We'll get to the DMZ and I'll talk about DMZ, but as a rule of thumb, any interface name except for the word inside is set to 0. Any interface name. In outside, internal, even internal will be set to 0 because it's not inside. External, DMZ, whatever you want to call it, servers, it'll be set to 0. So far, so good? You guys okay with that? What's the significance of the security level? It's very important. For a 9.x firewall or below, security level plays a big part in the way traffic is allowed or not allowed on a network. Okay, what do I mean by that? Let's say by default I go in on this network and I set this interface name over here. Oops, wrong one. I set this name over here to be outside. Okay, and I set this name over here to be inside. What is the security level set over here now? Automatically?
0.
And this guy over here, automatically 100. Agreed? Now, once this is set, there are certain default characteristics of a firewall that are going to either allow or deny traffic. All traffic traversing from where? A high security level to low security level is going to be allowed. It's going to be not only allowed, but it's also going to be inspected for TCP and UDP traffic. Inspected means what? Whatever is going out, it will be checked and allowed coming back. This is allowed. Even the reverse, because of what? This inspection. Okay? Any traffic coming from where? Out to in. Blocked. From 0 to 100, it's blocked. What about traffic that went from in to out? Let's say this guy over here, there was a PC down here. He browsed to, let's say, a web server down here. Let's say www.cisco.com. The packet went out. As it went out, it's allowed to go from high to low. But whatever traffic is allowed to go through the firewall is also what? Inspected. Inspected means it's going to create the return entry and put it into a state table that would allow the traffic to come back in. SCIP is based on what protocol? Yeah, but what protocol is it based on? It's based on UDP. TFTP, UDP based. FTP, TCP based. So all your protocols that are upper layer protocols are based on either TCP or UDP. The problem will be protocols like ICMP. ICMP is its own protocol. It's not running all on top of TCP or UDP. What is a connection entry? What a connection entry is like this. When you make a connection, let's say this guy over here is making a connection, this client, FTP will be allowed from where? In to out or out to in? Out to in, nothing is allowed. In to out, everything is allowed, and return. Connection in to out will be allowed. All right, so let's take a look at it. Let's say I'm doing a client connection. Let me go through this and you'll see it. When I make a connection, 192.1. Let's say my IP address on this client is 10.5. I make a connection to a web server. How does the traffic flow? It's flowing from where? From high to low. Agreed? Okay, so as soon as it hits the firewall, it says, oh, it's going from high to low, I need to allow it. It doesn't just allow it, it's going to this web server. Let's say this web server over here is 199.111. What does the packet look like? A normal web packet look like? It has a source IP of 192.1.10.5, this client IP. Destination is 199.1.1.1, which is the destination IP. Okay. It has a source port. For web traffic, the source port is random, any number, about 1024. So let's say it's 21111. Destination port, I'm going to a web server, it's going to be port 80. This is randomly selected. Everybody okay with it so far? This is the packet that's going out. As it goes out, the firewall over here checks this packet, says, oh, it's allowed to go out, and it inspects it and creates an entry in a table known as the connection table, also known as the state table. In this connection table, it sees that the traffic going from in to out is from 10.5 to 199.111. Source port is this, destination port is that. It creates a reverse entry, which will allow return traffic coming in from 199.111 going towards, which is the reverse of this packet, from a source port of 80 to a destination port of 2111. It creates it and puts it into the connection table. Allows the packet to go out. Hits the web server. Web server receives this packet. He will create the return packet. What does the return packet look like? Source port is 80. Destination port is 2111. Sends a packet back. Hits the firewall. The first thing that the firewall does, it checks the connection table. If the connection table is allowing this return packet to come back in, although it's going from 0 to 100, it is going to be allowed because this is return traffic. This is traffic that actually was initiated from inside to outside, so the return packet is automatically allowed. Everybody okay with that? Connection table is created for any traffic that is allowed to go through the firewall. So even if traffic was allowed, manually allowed from outside to inside, it would also create a connection table for it. Because it speeds up things. It's like caching the entry. So if I do that, yes, we can see the connection table entry. I'll show you that. Reflexive ACL does the same thing, isn't it, sir? Yes, that's a very old mechanism of doing it. But inspection allows you a lot more capabilities. We'll, for right now, understand the basics. I'll also explain what is the main difference between reflexive ACL and what I'm doing over here. This is stateful inspection. That is correct. Show con is the command to see it. Yes. You understand how it's working now? But now let's say somebody wanted to come from outside to inside. That traffic, which is initiated from the outside, it is not return traffic. When it hits a firewall, okay, thank you. So if traffic comes up from the outside to inside, it hits the firewall. the firewall by default will block it. By default, the firewall will block it. What if you did want traffic to come in from outside, from the internet, maybe to your web server? If you did want to allow that traffic, you can do that by creating an explicit ACL that allows the traffic to come in from outside to inside. That capability is there. You do have the ability to do that, but you need to manually do that. Whereas the traffic from high to low, by default, is automatically allowed. Now, one of the things that you should do, and that's where the concept of DMZ comes in, you should not allow traffic coming into your corporate network. If your public-facing servers are over here, maybe server 1, which is your web server, which people are accessing from the internet, or maybe server 2, which is maybe a DNS server coming from outside, those servers, you don't want to put them on the corporate network. What you generally would want to do, and that's where the DMZ comes in, you create a separate interface where on your firewall, a third interface. On this third interface is where you would put all your servers. So maybe your web server, maybe your DNS server, maybe your email server, you would put them down over here. Everybody okay with that? You guys understand that? So this is where you would create a third interface, and this third interface that you would create would be maybe a security level between, doesn't necessarily have to be exactly middle, but has to be higher than the outside. So when a traffic goes from outside to DMZ, it'll consider to be low to high, and it should be lower than inside, so the DMZ server should not have access to the corporate network. So generally the most common name given to this network is the word DMZ, demilitarized zone. So it's a little bit more open than your corporate network in the sense that you do allow access from the outside to it, but you don't allow those servers accessing your inside network. So you're protecting your inside network, basically providing collateral damage. What does collateral damage mean? That basically means if the servers go down, they don't bring your corporate network down. All right? So over here, you would put your web server, maybe. By default, outside to DMZ or DMZ to outside packet allowed. Let me ask you that question. What was my rule that I told you? Low to high, allowed or not allowed? Low to high, is it allowed? Low to high, not allowed, right? So if it's going from outside to DMZ, it's going from 0 to 50, it's not allowed. High to low, inside can access your web servers, but not the web servers cannot access your inside, means they cannot initiate traffic. If the inside accesses the web server, it will get a response back because that would be inspected. Good question. What if two interfaces have the same security level? In what situations would you want to keep it? By default, if you put two interfaces on a firewall with the same security level, these are interfaces that you never want to allow communicating to each other by default. But before I go into that, Manpreet, let me just make sure you understand this part, and then we'll go into that same security level. So I've set it up with 0 and DMZ. I've specified that the DMZ security level is 50. I would go and manually do that. Now, because I did want people from the internet to be able to access what? This server, let's say this server on this network, let's say this network over here is 192.1. 30.0, and this guy is 11, this guy is 12, this guy is 13. I do want people from the internet accessing 30.11 for what service? For web services. Put that in your ACL. You need to allow that in your ACL because by default, it does not allow that traffic to come through. Okay? So by default, when you allow when you have this web server over here, because the traffic is coming from a low to high, 0 to 50, the traffic will not be allowed. If you do want to allow that traffic, you need to create what? An ACL on the outside interface permitting access to this particular network. Which network was that? Let's say this network over here happens to be 192.1.30.0. And let's say this guy over here is .11. This guy is .12 on that network. This is 13, right? Now, I would need to allow an ACL over here that would allow the traffic coming from the internet. This is not the syntax. I'm just going to show you what I'm trying to do. Permit any on the outside to access what? 30.11 for what services? 80 and maybe 443 because 443 is your HTTPS. Do you guys understand what this ACL did? But I need to create this ACL on the firewall because I do want to allow traffic manually to be able to come in from where? From a low security interface into high. I need to manually do that. Okay, same thing, ACL, permit what? Anybody coming into 30.12, but for what? Only for 53, which is the port number for DNS. Again, an ACL entry permitting what? Access to 30.13 for what? 25. Do you guys understand what I'm trying to get to over here? So if I do want to allow access from low to high, you do have the capability of doing that, but you need to manually do it. So if you have a low to high, you need to manually do that stuff. But can you do it? Sure you can. Clear? Now that you understand certain flows, let's write them down. Security level controls the traffic flow. If the traffic flows from high security level to low security level, it is allowed by default. Okay, it is also inspected so that the return traffic can get back. Good. That depends on company to company, Faisal. That depends on company to company. That is not always the case. Okay. So traffic flows from, it is also inspected so that return traffic comes in. If the traffic flows from low security level to high security level, it is blocked by default. Okay? If you would like this traffic to go through, you need to create an explicit ACL allowing this traffic. like I showed you how to do it. Everybody okay with this so far? Now, coming back to that question that we talked about in terms of the having two interfaces with the same security level. In some cases, you might have this type of setup where your firewall has an outside, has an inside, has a DMZ. Okay? It also has some other interfaces connecting to partner networks. So partner 1, partner 2, partner 3. So they're coming in maybe through an MPLS VPN. Different networks. This is your internet. Okay? Now what you want to do is you want to allow P1 or P2 or P3 access to your DMZ. Good? But you don't want partner 1 using you as a transit to get to partner 2. Or you don't want partner 2 to use you as a transit to get to partner 3, and so on and so forth. But you do want them to come in and access my DMZ through a corporate network. Okay, if that's the situation, what you want to do is you want to set, let's take a look at, again, as an example, this would be 0, this would be 100. My DMZ, I'll keep it as 50. I will keep all my partner networks at the same level. I'm going to assign all of them a security level of, let's say, 25. Whatever I assign to one, I'll assign the same level to the other one. Now, what happens is when you assign different interfaces the same security level, a couple of things happen. Number one, in terms of it communicating to the DMZ, because it's still lower than the DMZ, you still need to create what? And have an interface ACL on these interfaces to allow it access to a higher level interface. Does that make sense? Okay. So you would still need to create the ACL allowing P1 accessing certain servers on the DMZ. Maybe you want to limit it to specific servers. You want to do the same thing on P2 and same thing on P3. But at the same time, I don't want P1 communicating to P2 or P3. When I set the two interfaces with the same security level, automatically they will not be able to communicate to each other. Even if my ACL on the interface is permit IP any, it does allow access from low to high with permit IP any, but it does not allow you access from 25 to a 25. Same security level by default is not allowed. Do you get my point? So this is the typical scenario where you would want to have two interfaces with the same security level. When you do that, even a IP ACL will not help you allow it. I'll get to that. It's not intra. Intra would mean what? Intra would mean if I'm doing what? A hairpin, come in and go out of the same one. Now inter, understand the concept first. You guys understand why I would want to do this first? So if that's the situation, that's where you run it. I don't want you guys just to know the command. I want you to understand why would you want to do that? What's the purpose of having those commands? So by default, when you set it up, you do it for the purpose of to isolate one segment, one interface from the other stuff. So if that's the situation you're in, this is perfect. This is exactly what you want to do. You want to put the P1, P2, and P3 interfaces with the same security level so they don't use you as a transit to get to each other. And in some cases, you might just want to put all of them as 0. Why? Because even with this, they can use or leverage your internet to go out because the internet is 0. So they can come in from P2 and use internet to go out. So if you don't want them to do that, set all of them to what? 0. So they won't even be able to communicate to what? The internet through you. They cannot piggyback on your firewall to go to the internet. This is another situation that I've also seen. But there's another way, another situation that you might want to have. You guys are okay with this? This is one way of doing it. The other way of doing it is where you do want them to communicate to each other. I'm going to show you a completely different scenario, a completely different company. In this company, company B, I have outside 0. I have 2 or 3 different internal interfaces. Let's say this is sales 1, sales 2, sales 3. 3 interfaces that are on the inside. I want all of them to be like the high interface. So I give all of them 100. Now sales 1 cannot communicate to sales 2, or sales 2 cannot communicate to sales 3. Correct? No, 3 different interfaces have to be on 3 different subnets. Right? If you go to a router, can you assign 3 IPs belong to the same subnet to 3 different interfaces? It won't let you. It'll say, hey, this address is already being used on the other interface. So it has to be 3 different interfaces. Good? Now, what if you don't want any firewalling to be done from 100 to 100? That's a situation. I don't want any firewalling. These are all part of the same department. They just happen to be 3 different subnets. So there is a command that's like an on or off command. By default, same to same is not allowed, but you do have the ability, if you want, to turn it on. You can say there's a command called same security traffic permit. It's a single command, single line. Inter interface, I believe. Now I have gone from where? Not allowing any traffic to go through to what? Allowing all traffic to go through. So in this situation, this is something that you would do in situations where I have multiple interfaces that belong to the same security level, and I don't want any firewalling to be done. I want all traffic to be allowed from 100 to 100. Do you get my point? It's this way or that way. You cannot do it per interface. You cannot specify. If you want to specifically allow traffic between sales 1 and sales 2, then you can go in and control it by using an ACL on the interface. But in this case, the default policy would be to allow all traffic from 100 to 100 if you do that. But then you can, again, go back and control based on an ACL. If situation sales 1 person only wants to talk to sales 2 and not to sales 3, again, there are different ways to do it. If the sales 3 one is completely different, put that at a different security level, maybe 50. Control it that way. But if you want certain traffic to be allowed, you can always use an ACL. Without doing anything, you don't need an ACL. If you do same security traffic permit interface, by default, now there's no firewalling done between these 3 interfaces. It depends on the company. See, Ahmed, you need to take a look at the business requirement. If the business requirement is that you need 3 different interfaces that need to be able to talk to each other, I don't want to do any firewalling between them, then you do this. There's no one thing that is always good for all networks. That's one thing that you need to understand. So when would I use this type of design? When you have multiple subnets that are connected to the firewall and I don't want any firewalling done between those three subnets. So I would just put them on the same security level and say same security traffic permit inter-interface. But keep one thing in mind, you can do this or that. You cannot do the P1, P2 example with this at the same time, because this command is a global command. What do I mean by it's a global command? So you either allow all traffic to go through it based on this command, or leave it at the default, which allows no traffic to go through. Everybody good with this? So you understand that? For same security level, what about it, Shiv? We can use the same interface level command, same security traffic permit inter-interface.
What? From the same interface, right? We can use for example, two interfaces that are part of the same security level, right? So
you do it globally.
So we can use, rather than doing it globally, we can do it interface level as well, right?
No, this is all. This is a global command. So you're turning on or turning off the feature.
Turning on.
Yeah, it's a turn on or turn off feature. It's not like you're doing it between these two interfaces, not those two. You cannot do that. Either you specify that anytime you have what? If you have two interfaces that want to talk to each other all the time, then you use this command. If you don't want them to talk to each other at the same time, turn it off. So you cannot be specific. You cannot say, oh, these two interfaces, I want them to talk to each other, and these two, I don't want them to talk to each other. You can't do that. You understand what I'm saying? So it's not something that you can do selectively. It has to be done globally.
Globally. Okay.
All right. So one situation or the other. I want you guys to understand, whenever you do networks or whenever you do any type of technology, understand one thing, and that's something that I feel that is not stressed enough in the lower end classes, is technologies are made for a specific reason. You need to pick the appropriate technology based on the requirement of the client. That's why you have so many different variations to do it, because you need to take a look at what the business requirement is and try to match the appropriate technology for it. So that's why they gave you both capabilities. Now it's up to you. It's up to the situation you're in terms of which technology would be better suited for that particular type of setup. Understood? So keep that open mind to be able to do that. So now you're clear about the flow of traffic from high to low, low to high. You also know how to configure interfaces over here, right? So let's go ahead and set that up. I'll set up a very basic network today that we can use. We'll do this type of network. Forget about the DMZ for right now. My job today is to show you a small network where I have router 1 on the inside, router 2 on the outside, and I will allow you to go from high to low and maybe allow something to come back in. Okay, so I have my environment over here. I have an ASA1. I have a couple of routers, CSR1, CSR2, that are connected to each other. The topology is just like this. I have firewall, the ASA over here, connected to a router 2 on the outside, router 1 on the inside. I'm going to fire them up. Over here, I'll open the console for ASA1. It's blank right now. Show version. I'm running 9.6. You guys take a look at it. Do you see that? The version is right over here. Good. So let's take a look. And at the same time, I'll also bring up my two CSRs. Open the console. R1 is the CSR1 is one on the inside. I just want to check what I have on it so we can. Blanket. I'll default my loopback gig 1. It's a router. It's a virtual router. You need to ask Vikas that. OSPF is there. Gig 1 I'll get rid of. IP routes I'm going to get rid of. All right, so router 2 is on the outside. Router 1 is on the inside, just like our diagram over here. Okay. And firewall is in the middle. Forget about the DMZ right now. I'm just working off this stuff, outside and inside. Okay. Let's configure R1. So let me just minimize these things over here. Okay. Let's go to R1. If you take a look at your network over here, my inside network is 10.0. I'll set this to .1 and the firewall will be .10. So that's what I want to do over here. Interface gig 1. IP address 192.10.1. All right. I'll create a loopback simulating as if I have those internal networks. Remember, I told you that I have these. Okay. So now I'm simulating as if I have what? This is my outside network. Which one? This guy over here. Gig, this one I'll get rid of. I'll shut this interface down and I have 3 inside interfaces. Gig 2, shut. All right, so I have 10 on the outside and 3 inside loopbacks, just like my router over here. Let's do the same thing on router 2. 20.0 should be the gig 1 interface, And the internet, I'll just create a loopback to simulate the internet, like 2222 or something like that. So let's go to router 2 now. Interface gig 1. Let's say 20.2. No shut. And this is going to simulate as if I'm on the internet. Two interfaces over here. Good so far? Everybody okay with that? I've configured my two routers. Now comes the firewall part. Okay, let's take a look at the firewall. So how do I configure it? Interface gig 0/0. This is my outside interface. Is it? No, gig 00, my first interface is towards the inside. Okay, gig 00 is towards my inside. So I need to give it a name. Right now, if I do a show run interface gig 0/0, you will notice it has no name given to it, no security level, no IP address, and it's in the shutdown mode. So what I'll do on this interface is give it a name. The command for that is nameif, and you specify the name. I'll say the name is inside. Notice I put the I uppercase, N S I D E in lowercase. All right, clear. IP address 192.1.10.10 because it's on the inside. Now, one of the things that you can do on the firewall, what's the mask that I've been using for this? /24. It's a Class C network with a Class C mask, which is the default mask, right? For a Class C, the default mask is 24. On the firewall, if you want to, you don't need to specify the mask. I can just press enter. It'll take the IP address and the mask will set it to the default mask for this particular network. For Class C, it will be a /24. Okay, if you want to type it out, it's no problems. You could do this. This is not an issue. This is also going to work. But notice a message that popped in over here. What did it say in the message over here? It says info. It's not a bad message, just giving you information. Security level for inside is set to 100. Why 100? Because of the word inside. As I said, it's not case sensitive. Whether you type in inside with all lowercase or inside with I capitalized or the whole thing is inside, as long as it's inside and there's no security level assigned to it already, it's going to set the security level to 100. For the name of the interface being inside. Good, everybody? Now coming back over here, I do need to do no shot to bring it up. Ping 192.10.1. Who's 10.1? The inside router. I can ping it. Everybody okay with that? It depends on the console logging that you turned on. What type of logging have you turned on the router or on the firewall? Now, term 1 is for telnet only. So it's a logging level that you've turned on. You're going through the console You'll see it.
Yeah, login console. You can just enable login console or something like that.
Yeah, so it's based on what logging you've turned on. That's why you're seeing it or not seeing it. Now, I need to do the same thing on the outside. The outside is gig 01. How do I do it? Gig 01, name if is short for interface. Let's call it outside. Take a look at the message this time around. Security level for outside set to 0 by default. All interface names except for the word inside will be set to 100 as long as there is no security level already assigned to it. If there was a security level assigned to it, it doesn't override it. But if it's no security level, it'll change it to either 0 or 100. You will see that in your running config as well. So if I do show run interface gig 0/0, now you'll see security level as 100 and 01 will be as 0. I haven't given it an IP address. Let's assign it an IP address. Let's say 20.10. And it's up to you if you want to type it in or you don't want to type it in. Don't forget no shutdown. So now you have gig 0/1 and 00 both set up. And this time around, I should be able to ping 20.2. So now I have communicated, I have direct communication between the firewall and the directly connected devices. To do show route, which is equivalent to the show IP route command, you will see the two networks that you have, inside and as well as outside. Take a look. The connected networks, the two connected networks are what? Directly connected, inside, directly connected, outside. Everybody okay with that? Now let's say I want the firewall to be able to go to the internet. I don't want the firewall to get all the routes from the internet. So what do I generally do on a device if it wants to face the internet? I give it a default gateway pointing towards what? The outside. Let me put these commands in for you first. Interface configuration example. How did I do it? Interface gig 0/0, name if, inside IP address was 10.10. If you want, I can put the mask in here as well, so that you guys don't get confused. Now, the next thing I want to give you, do over here is the configuring the default gateway. Do you guys remember how you did it on the router? How do you put a default gateway on the router? What's the command for that? IP route 0000, 0000, and the next hop, right? Well, the route command, which is your static route command, on the firewall is a little different. You say route exit interface, the name. Which interface am I using? Okay, followed by the network and the mask. If it's a default gateway, it's going to be 0000, and then the next hop. This is your default gateway command, or your static route command for the default gateway or a normal route. So if I'm doing it for, let's say, for the internet, how would I do it? Like a default gateway. Route, default gateway is towards the outside. Notice I put outside with all lowercase. It's absolutely okay. It is not case sensitive. So outside, uppercase, lowercase, it means the same thing. Now, if it's a default gateway, I can do this. Or if you want, the firewall does give you the capability of putting a 0. 0 represents all zeros. So when you put a 0, it means all zeros. The second 0 is the second set of zeros. And then the 20.2. You can write it like that. The default gateway towards the internet. Let's take a look. Let's do this. Route outside 0, 0 pointed to 20.2. Who's 20.2? Is that router 2 on the outside. Now I want you guys to see something. How did I type in route? I typed in route with the outside with O lowercase. But when I created the interface was O in uppercase. Take a look what I mean by case preservation. It preserves the case. When I did the route, I put it in lowercase, but it knows, hey, listen, you know what? When you created it, you created outside with O capital, so it preserves it. So it'll automatically change it. But it's not case sensitive, because if it was case sensitive, it would not take the command. That's called case preservation. So it preserves the case that you created at the offset. Show, there's no do over here, Fazil, on a firewall. It's just show run. There's no do. You can do the show commands from the config mode. Good. Now, if you remember on CSR2, I had that 2.2.2.2. If you take a look, I have the default gateway at the top. I don't have 2, but because of the default gateway, I should be able to ping 222 from the firewall. Clear, everybody? Now, I still need to complete my topology. What topology do I have to complete? If you take a look at your topology, the firewall now has a default gateway up towards R2. Firewall has no idea how to reach 192.1.1 or 192.1.2 or 192.1.3, which are from the inside interface towards 10.1. So let's create a static route for that as well. And it won't be a default gateway, it'll be normal static routes that you create using the same syntax. Route, exit interfaces inside the network, and the next hop. Next hop is R1. Same next hop. Yes, not today. We'll run a routing protocol tomorrow. So I'll show you that one as well. Right now, I want to show you a static mechanism. Show route. All the static routes are created. Everybody okay with this? Now, to complete the topology, I also need to create the static routes where? On the routers themselves. So let's go to router CSR1. CSR1 is on the inside. So over here, I'm just going to create a default gateway. Like this is a normal router. So .10, which is the firewall. You haven't done static routes on a router, Ajay, before? Or why, if the next hop is a firewall, why we do not need exit interface of the router? Meaning, on a router, you don't have an interface name per se. It's a completely different syntax. Just uses the routing table to figure out how to reach a particular one. There's no concept of a name on a router, right? The name of a concept is only on the firewall. Two different operating systems. Now, at the same time, can we configure gig 00? Yeah, you can, but you still need to specify the IP address, right? Otherwise, who's your next hop in terms of the IP? Now, R2, over here, R2 needs to be told that if it wants to reach 10.x, 1, 2, or 3, it needs to go through the firewall. I need to put those routes on the R2 device as well. So I'm completing basic routing over here, nothing out of the ordinary. So my reachability is established. 10.0 through 20.10, which is the firewall's IP address. 1 is reachable through it. Two and 3. So these are your, if I want to pick only on static routes, these are my static routes. So I have established what? All the connectivity part of it. What I'll do on router 2, just to show you this basic stuff, I'll set up telnet on router 2. Okay. I will go to router 1. I'll say telnet to 2.2.2.2. Now this traffic is going from what? Router 1, which is on the inside with a security level of 100. Going towards what? Outside, security level is 0. Will this traffic go? In to out. Will the traffic go? Yes. Not only will it go, it will also come back because of what? The inspection. Can you see that? Check. Show con. It's allowing traffic from where? This is the return traffic, by the way, guys. It's allowing TCP traffic from where? 2222. Source port number is 23 because this is the return traffic, which was inspected from in to out. This is allowing for 10.1. 40848 was the random port that was elected. So router 1 could telnet into router 2 because it was going from in to out. Okay, so let's go back over here, exit. I will set up telnet on router 1 as well. Good. Can router 2 telnet into router 1? Why not? It's going from low to high. Low to high traffic is not allowed by default. What if I did want to allow low to high? Specific traffic. I want a telnet to work. I want a ping to work. How do I do it? Go to the firewall, create an ACL, the syntax, ACL, the name, whatever you want to call it, just a name. It's a named ACL. There's no numbers. It's always a name. It's always extended. So access-list ABC, just a name, permit, the protocol, which is TCP. I want to be more specific. I'll say host 192.1. Or no, not. Return, I want to allow, yeah, 192.1.20.2 to be able to telnet to 10.1. EQ 23, which is telnet. Okay. I also want, let's say, ICMP to work. Ping. Permit. ICMP, any. Okay. So take a look at your ACL. So my ACL is created. It's always created as a named extended ACL. Permit TCP 20.2 should be able to telnet to 10.1. For telnet, that traffic is allowed. ICMP is allowed. The rest is, there's an implicit deny any that will block everything else. Router 2 wants to reach router 1, allow R2 IP to outside IP of firewall. No, I want to reach R2 to, I want router 2 to reach R1. So I need to allow who it needs to reach, not the IP of the outside firewall. My packet that's going to come in from R2, it's going to come in from R1, not for the outside of the IP. I need to apply the ACL to the outside interface. Do you understand what I'm saying, Ahmed? Router 2 wants to reach router 1, so in my ACL, I would put router 2 as a source, router 1 as the destination. Okay, I need to apply this. How do I apply it? The syntax for applying it is access-group, the name of the ACL, which is ABC, direction, which is inbound, and the name of the interface, outside. So I'm applying ABC in the inbound direction on the outside interface. Let me write this down for you guys. So this was a route. This is route inside. 10.1. I did 3 of those. Finish this. The port number is a source or destination port number. It's the destination port number. If you want to specify the source port, you would do it over here. Generally, the source port is random, so you leave it off. So access-list ABC. When I say permit TCP, I said host 10.1. If I wanted to specify a port number, it would go over here. But I don't know what the port number is. So if I leave it off, it means any port number. Destination is, sorry, 20.2. I leave the port number off. So when I specify a destination port, it goes with this. This is the destination portion. That's CCNA though, by the way. And ACL. This is the destination port. This is the source port or source portion. And this is the destination portion, including the port number. Good. And then I also allowed what? ICMP to work. Good. Apply it. How did I apply it? ABC inbound to the interface outside. So I'm saying check the ACL ABC on the outside interface. So if it's not in the connection table, it checks the ACL. Oh, this traffic is allowed. Let the packet go through. Let's test it. We didn't test it. So now, remember this telnet did not work. If I do it now, it should work. So now this allowed traffic from outside to inside as well. Cool? Basic flow of traffic through the firewall, basic routing using static routes on the firewall. I put all the different commands so far. So tomorrow, we're going to do a review of this, set this up again. You'll see, get a chance to see it again. We'll do dynamic routing protocols.
The first access list should be 192.1.10. I guess.
No, you're right, but over here.
Yeah, destination.
Yeah, destination.
Fine.
Yes, Ahmed, I'm going to send it to Vikas along with the diagram and the MP4 file. You get it from him. So tomorrow we'll take a look at the review of this. Thank you. We'll do dynamic routing protocols. Not only that, tomorrow, what else will we do? We'll take a look at some smaller other things over here. My main focus will be dynamic protocols, but we will move forward from it. So this is, I have a file. All right, so this is done. And that's it for today. I shall see you
Hi,
at the same time.
but I joined today very late and just half an hour before I have joined. Can I know what is done today? Can I go for this video again?
Yeah, go. Vikas must have given you the link. I'll be sending the whole video to Vikas so you can look at it from scratch.
Okay, fine. Thank you. Thanks, but
No problems. So what we've done right now is basic configuration is done. We've done basic routing. We haven't done the entire routing. Traffic flow we've done. So tomorrow we'll do routing on the firewall, which is dynamic routing. And we will, after dynamic routing, we'll also take a look at some smaller things like ICMP to the firewall, management of the firewall, like telnet to the firewall, those type of things. And then we'll take a look at NAT on the firewall. Probably not tomorrow, day after. And then the last thing is,
are you going to take tomorrow classes or not?
yeah, every day.
Okay, but thank you.
Monday through Friday, same time.
Okay, thanks.
Thank you. Thanks, sir.
Thank you so much. Yeah, again, Faisal, these things, when you say these type of things, usually it depends. It really depends on the situation of the network. 8 to 10, yeah, 8 o'clock. So see you guys tomorrow, same time. I'll send the file to Vikas. As soon as the thing is done, the rendering of the file is done, I'll send it to Vikas. Probably another 30 to 45 minutes. Good night.
Good night, sir.
Good night.
Good night.
Thank you.